Hello and welcome. My name is Tyler Evans and welcome to the Electromagnetic Spectrum. In this presentation, I want to introduce you to the electromagnetic spectrum, what it is, how it was discovered and what it means most to us, and the many ways we encounter the spectrum within our lives. Now, if you would indulge me for a second and close your eyes. Now, while I know you're probably not going to do that, but humor me for a second. When you woke up this morning, think of the first image you saw. If it was dark, you might have seen shadows in the room or even a hint of sunlight come through the window. You may have heard sounds from outside, possibly. Now, fast forward a bit to breakfast, or maybe your quarantine breakfast warmed up in your microwave. At work, in all of this, we often don't think about it, but you guessed it, is the electromagnetic spectrum. So to adequately explain what the electromagnetic spectrum is, there are some few words we need to go ahead and define to make it easier to understand. First is wavelength. Now, wavelength is a measure between two crests, or peaks, in a waveform. The crest, being the very top of the wavelength, is where you're going to find the peak of that energy. The trough, or the bottom of the wavelength, is where you're going to find the least or low point of that energy form. Now, the longer the wavelength, the less power it has. The shorter the wavelengths get, the more energy is generated. Now, these wavelengths are typically referred to as frequencies and measured in hertz. For example, a wavelength with a frequency of 1 hertz will pass 1 cycle per second. Now, these frequencies make up everything from radio waves to microwaves, infrared to visible light, ultraviolet to X-rays, and at the end we have gamma rays. Now, the primary form where we're going to find most of this stuff on our day-to-day is within visible light. The visible light spectrum starts from increasing from red, orange, yellow, green, blue, indigo, violet, also known as Roy G. Biv. While the entire spectrum is measured in 3 various measurements, wavelengths, nanometers, and electron volts, majority of the visible light section only covers a small portion of the spectrum, which we find here, between 400 and 700 nanometers. So where did the study of the electromagnetic spectrum begin? In an article on livescience.com, a University of Virginia physics professor, Michael Fowler, stated, "The first person to realize that white light was made up of colors of the rainbow was Isaac Newton, who in 1666 passed sunlight through a narrow slit in a prism and projected it on the wall. This, of course, changed in 1800 when British astronomer William Herschel was documenting temperatures of sunlight refracted through a prism. He noted that there was a jump in temperature on the edge of the red portion of visible light, leading to the belief that there was more beyond what was present. This light eventually was termed infrared light, literally below red light. Now, beyond ultraviolet, we typically get from sources like the sun, we find X-rays. Now, part of this spectrum was discovered in November 8, 1895 by a German physicist named Wilhelm Röntgen. At the end of the gamma rays, which carry the most energy, naturally create within the universe, but can also be synthesized by humans. Now, other than visible light, we have many ways that we encounter the electromagnetic spectrum. First being radio waves. Now, before the days of 8-track tapes and cassette tapes, we used radio waves to listen to music in our car. It also enabled the ability to communicate over various distances. Microwaves are commonly used in day-to-day in our very own household with, you guessed it, the microwave to heat food. Microwaves are also used as security sensors to detect movement within an area. Next on the scale is infrared, or near red, as we discussed earlier. Infrared has multiple uses commonly found in remote controls for TVs or RC controls. Now, visible light is made up of the sun's reflected light, often seen in rainbows during rain. The sunlight reflected through little raindrops all at the same time produce the image of the rainbow. Ultraviolet light is used within detection for law enforcement and various cleaning methods. X-rays, commonly used in the medical field, are similarly used in security such as TSA check bag systems. Gamma rays are also some of the most interesting of all. Now, as we've seen, they hold the most energy, being the shortest wavelengths we find in the spectrum. These rays can be synthetically made in the medical field to image the inside of the human body, but one of the most incredible natural occurrences is aurora borealis. This phenomenon happens when the sun releases incredible gamma energy and interacts with our Earth's atmosphere gases. The various levels of gamma penetration into our atmosphere make up the unique color and variances that we see. The electromagnetic spectrum is found all around us and interwoven in almost everything we do. Today we covered the basic understanding of the electromagnetic spectrum, which makes up all parts of it. We reviewed how it was discovered and a portion of the range, visible light, that we use the most. Finally, we highlighted the various uses we have for all the parts of the electromagnetic spectrum. Thank you for listening today, and I hope you gained some insight into the world around you and some forces you may not see.